Last call.
You were talking a lot about the security and such, but how many different layers of security do you want? And is it dependent on what kind of access you're going to have to the information?
Yeah.
You said we're not going to be doing control as far as like the solar panel. You don't want to have control over it, but would that change depending on what kind of actor you're going to be?
I think your security architecture, the levels of security in your architecture, is going to depend on which products you use. You know, for instance, Adobe may have a certain type of security on it. Flash may have a different kind of security. If you do the communications and access to and from the database archive, you know, you'll probably be using some kind of SQL database representation that has some security features built into it. You know, I don't think that you're going to be developing any new security features. You'll be utilizing the security features that comes with the apps and the layers of communication that are already in there. Now, one of the problems that you get into is that a security feature here in the database management system, or the communications between here to here, may not use the same security as, let's say, the same encryption mechanism.
Right.
So, you know, that's what the power of this enterprise service bus is, because you can come in here with a smart building security encryption mechanism. It'll hit XML and it gets transferred into a common common format, and then from here you can transfer it into the storage format encryption method. See, that's why this guy's kind of like a translator. It's almost like a common language. It's been the way that it's described is you say, okay, if this guy is speaking French and this guy's speaking German, and they don't talk to each other, they don't know German or French, then you need a translator. That's what this is.
Thank you.
That's a good question. Any other questions? Yep.
Going back to the level of abstraction, you were saying that you can get data readings from a building or possibly even an office if we have the time to implement that. And considering how big UTEP gets from now till 10 years, will that data be available so that we can read per office, like per classroom, I guess, electric consumptions?
Yeah, I mean, I think that the level of abstraction depends on how you want to quantify these levels of abstraction. Let me give an example. For instance, there's 90 buildings on campus. Okay, let's say that there's an average of 200 rooms per building. I don't know if that's right or not. I'm just picking some numbers. So you got 90 times 200 is what, 1,800 rooms, basically. And so in those rooms, you may be measuring lighting, air conditioning, temperature. You know, so you've got three data values for each room. Real simple. And then at 3 times 1,800 is what, 5,400. So you're not looking at a lot of data values. The thing that you need to be aware of is how extendable, how scalable is the word, how scalable is your architecture, your software architecture. Because you want to go from 3 buildings to 90 buildings, and you want to go from one building has 200 rooms to a building that has 500 rooms, right? So that's a scalability feature. And you have to calculate that at the beginning before you start coding, because you want to have that scalability built in so that when you have, let's say, 120 buildings with 500 rooms average, then these guys can take the data. And then if you consider these smart meters, these are smart meters that read they can read, I guess, to every minute, you know, if you want to. But every 15 minutes, that's four readings per hour times 24 times 365. That adds up, you know, per year. So the data that you're accumulating gets into what we call big data, where the size of these databases starts growing, you know, as the years increase. Now, in some states, the utilities like the smart meters and so forth, they require the utilities to keep the data for 10 years. See, so that's why the storage of this data is so important. And like I said earlier, if you have 1 million meters or 5,000 or 5 million meters, then that becomes a big data problem. And this has to be scalable to match that big data collection, storage.
So
That's a good question.
we'll hold Carlos' question and then we'll follow it up. So, yeah.
You were saying that the smart meters do readings every 15 minutes.
Right.
Will the transformers, like except for passive electric, be able to do readings quicker in order to accommodate the seconds of response time you'd like?
Yeah, so there's two different things here, and the electricity, the amount of electricity provided to the campus is what's called the load. Every time we turn on a switch or turn on a computer, we increase the demand, the load demand for the campus. And then the electricity company already has reserve power so that, let's say, 200 people turn on the switches at the same time, they would be able to provide you the power for that. Okay, now, the smart meters, all they do is they measure that. See, they measure how much power you're using within the building. And it doesn't mean that you can control the flow of electricity with a smart meter. It actually provides you a two-way communications, but right now we're using the mode where we're just monitoring the smart meter. See, there's no control back to the building. There's ways to do that, but not for this class.
Well, thank you. And, well, let's take Dr. Martinez.
Anything else? That's it?
Yeah,
Okay.
we're out of time.
Okay, good.
Right? Well, yeah, let's take that. All right, so remember next week the transcript is due and we'll have a nice weekend.